All right. Hello, everybody, and welcome to Switch's first webinar called Switch to Clarity. This is going to be a series of webinars throughout this year, likely one webinar per month. And today we want to focus on a specific topic called OCPP 2.0.1. And I would like to introduce to you guys my colleagues. To the left of me is Hugo Chad. He's leading our development on the OCPP implementation. And we also have Chad here. He's joining us from Vienna at the moment. And he's also going to explain to you a few slides on this presentation. Hi, Chad. Before we get into the nitty-gritty of all of it, I would like to explain to you quickly how this webinar tool Crowdcast works. So on the right-hand side, you see the chat. There, I would like to, as some already did, maybe share with us where you're joining in from. I see we have people from Toronto, from Italy, from Ealing, from Spain, from Israel, Belgium. That's amazing. So keep on, tell us where you're from. When it comes to questions, I would kindly ask you to not put the questions in the chat, but right at the bottom right corner, you see next to the Say Something Nice, which is the chat box, you see Ask a Question. So when you click on that, you can pose a question, which we will come back to you in the Q&A session at the very end. And there's also the possibility to upvote questions that you find interesting. So we will answer the most relevant questions at the very end. And we have also prepared two polls, one at the very beginning, one at the end. And I think we're good to go, right? Perfect. Cool. Let's bring up the presentation. All right. So the title for today's session is The Case for OCPP 2.0.1. First of all, let me maybe give you a short background on what Switch is and why are we talking to you about OCPP 2.0.1. So maybe the next slide. We are in the business of providing software solutions for the charging station manufacturers on the one hand side, and providing an operating system for chargers that includes both OCPP 2.0.1, but also all the different versions of ISO 15118, the -2, -3, -20. And on the other hand side, we also provide solutions for the charging station network operators to manage those charging stations from small hotels all the way up to big delivery fleets. So that's where we come from. And I don't want to make this big of an advertisement about Switch. We are here about the content. So let's dive right into it. What is OCPP, and specifically OCPP 2.0.1? In order to understand that, maybe let's go from a macro view first and see what are the kind of standards in this market on the next slide. And this whole e-mobility market is kind of fragmented, right? So you have the cars, you have the charging stations, you have the charging station network operators, you have the mobility service providers, you have roaming networks. And with all these machine-to-machine communication, you need to have a clear kind of service contract, clear protocols that define how this information is exchanged. So we've tried to break it down to you in this one slide here. Let's go from left to right. So you have the electric vehicle that is connected to the charging station. And within the last 2 years, we have seen a huge uptake on at least announcements of cars and charging stations that will come to market with ISO 15118. And ISO 15118 is a digital communication protocol that is based on an analog signaling mechanism that is called IEC 61851, which you see on this slide there. So that's how cars have, specifically for AC charging, cars have been charging so far in a non-smart way. The charging station talks also to a back office system if it is connected to the internet. And the de facto standard here is OCPP, the Open Charge Point Protocol. OCPP has a long history of, I think, already 10, if not 12 years. And the most used version out there is OCPP 1.6. But since 2018, in April 2018, the Open Charge Alliance published the first version of OCPP 2.0. Now we are at the version 2.0.1. which comes with a whole new set of features, which we want to get you more into today. There's also another standardization initiative called IEC 63110 that was kicked off in early 2017. We might see it coming to market, or at least published by the end of next year. But for now, I think OCPP 2.0.1 holds everything we need. So that is the communication between the charging station and the back office, or charging station management system, however you want to call it. These charging station network operators, they need to talk to the entities called mobility service providers that provide the RFID cards and the service contracts for you as an end customer if you want to charge your car anywhere out there. So naturally, they have to exchange some information like authorization details, identification details. And in order to do so, there are established protocols as well. On the one hand side, we have the Open Charge Point Interface, OCPI, which started out as being more of a peer-to-peer protocol, but it is more and more also used to connect to charging hubs, such as Hubject, which also has their own protocol, the Open Intercharge Protocol. And also there we see a new standardization initiative, the IEC 63119, I think it is called.
110, yeah.
9, that's the
9?
Yeah.
Oh, is this the other one? Yeah.
That's the other one, exactly. And not sure when that will come out, but for now, OCPI and ICP, you can get easily confused with all these letters, are the ones that you should be focusing on. And in the end, the mobility service provider has the contractual relationship with the end customer, and then the invoice pops out every 30 days, so to say. So that's the ecosystem in which we are operating. And today we want to specifically focus on OCPP and OCPP 2.0.1. Let's head to the next slide. Right. As I was saying, we are working on solutions for a very holistic approach here for both charging station manufacturers. And that solution is called Joseph. And on the other hand side, we have Sarah, our backend solution for charging station network operators. I think the slides just, yeah, perfect. Let's head over to the next slide, please. And here we come to the new features of OCPP 2.0.1. And for that, I would like to hand over to Hugo.
All right. Yeah. Thank you very much, Marc. So yeah, a bit about OCPP. For this, I think the slides just went off, please. So yeah, a bit about OCPP and kind of its philosophy as well. So OCPP is an industry standard rather than like an international standard. And as such, it's been very pragmatic over the years, very much focused on getting things out that people are actually going to use, rather than kind of focusing on like abstractions, which are maybe happening a bit too early. And this is important to know for the distinction between 1.6 and 2.0.1, because 1.6, which was standardized quite a while ago, now is widely used, that has shown its limitations in the fields quite a bit. And as users and like charging station operators and networks in general have been using this technology, a lot of it has been fed back into the OCA for the next version of OCPP. And it is a quantitative jump between the two, and kind of themes that come out of the change from 1.6 to 2.0.1 is that there's much more complexity with 2.0.1 than with 1.6. There's a very good reason for that. It might seem like a bit of a barrier to entry for some, but it does reflect the use cases and the way people want to interact with this new technology. And this is now reflected in the protocol. So I will kind of just give a bit of a whistle-stop tour of what I see as the main benefits of 2.0.1 compared to the previous versions, to give you a bit of a flavor of what this new version brings. Today, of course, we will focus more on the device model. We won't do all of these, but yeah, it will give you an overview. So the first one you'll see is plug and charge. This is a really big feature that's been expected in the industry for quite some time. I think it was standardized in 2014, the first version, and had some very slow uptake. But now we're really seeing traction in the market. And OCPP 2.0.1 has a native integration with ISO 15118. So you can do some things with 1.6. It's an application note, more like a recommendation of how to do things. But the more advanced features, the fully functional parts of plug and charge really do come to light with 2.0.1. And as a reminder for people who are maybe not familiar with it, plug and charge gives the ability to the end user to just be able to come up to a charging station, plug in, everything is done in the background for them, payments, security, and they can plug out and then move on. Really trying to get to the simplest possible use case for customers. So plug and charge is one of these big new features. The device model, which we'll expand on later on, is another big thing, which is completely absent in 1.6. And the idea there is to open up visibility into charging stations and being able to see what a charging station is composed of. Are there any pain points? Are things slowing down? That is really the point of that device model, is increasing visibility of networks so that it's much easier to operate these charging stations. The next one is what we've been calling scalable transaction handling. So as the market has evolved, there have been many more different ways to actually interact with these charging stations. So to give you an example, where the traditional model of charging would just be to come up to a charging station, plug in, charge and plug out. That's still the case, but you might have a parking bay sensor, which will detect that you have arrived there and then trigger a transaction to the back end so that you can actually monitor when things are arriving. So the new version of OCPP really looks at these different use cases and how you can start transactions differently, looking at kind of pain points that are common in the industry and pulling that into the specification to increase interoperability. So it's definitely not as appealing to the end user as plug and charge and device model, but it really makes it much easier to operate, and it'll be easier to scale as we see more and more charging stations coming onto networks. The next one is advanced smart charging. There again, a big leap in improvement from 1.6. Also noticeable that we get smart charging with ISO 15118 with high-level communication. And yeah, those are kind of highly desired features as well, to do load balancing and things like this. Enhanced security, that is to be able to have a secure connection between the charging station and the CSMS. So being able to have either certificates on the backend side or even on the charging station side as well, to really beef up the security of the networks, which we've seen has been lacking up till now. And finally, multiple authorization methods. So in 1.6, what you have is you have RFID cards. If you want to charge, you have to go up to the charging station, swipe, and charge in that way. Here, we're really expanding into loads of different use cases. Plug and charge is one of them, using contract certificates on the car itself, rather than having a card. You can start using credit cards, PIN codes, even just having a start button on the charging station. It really is a much more fully featured, future-proof specification. So yeah, that was an overview, but now I think I want to expand a bit more on the device model. So next slide, please. Right, thanks. So yeah, to give a bit of motivation around the device model, kind of pulled together a few stats of the charging network in the UK. And yeah, this quote really kind of resonated with me, is that for a long time there was range anxiety, but now what's really becoming apparent is that there isn't that much range anxiety anymore, that EVs have improved a lot. Sure, for long distance travel, it's still a bit of a hassle, but by and large, most of that range anxiety has lessened to an extent, and charger anxiety has increased in tandem. And to give you a few stats as well on the UK, one of them is that it was this week actually that there was a one-day analysis of the quality of the charging network in the UK, and they found that 1 out of 10 charging stations, the rapid kinds, were actually broken at any given time, and that only 70% of charging sessions themselves they were actually successful. So yeah, we really see the device model as helping towards that. Obviously, it's not a full solution, but it will be a big point, and I'll kind of explain why. So yeah, next slide, please. So yeah, kind of 4 device model features that really like to call out. So the device model broadly is the ability to really give a lot of detail about the internals of a charging station to a backend system. So the first point is around auto discovery. So when a charging station is installed, the first thing that it will do is it will declare to the backend all of the components that it has. So it will say, I have this amount of connectors, I have EVSEs, and at the top level at the charging station, I might have some fans, and those are different configuration variables as well that come along with that. All of this is automated, so there's no kind of manual intervention required as well. The next point is around remote configuration. So the variables themselves, and examples of variables could be whether a connector is enabled or not, or what kind of the power limits would be on the charging station. All of those are reported into the backend and can be changed kind of dynamically, either by a person or by more sophisticated algorithms. And I think we'll see that as more and more companies get to grips with this new protocol, they'll really realize the power of kind of configuring remotely in that sense. And it is more sophisticated than 1.6, where we only have configuration keys. In 2.0.1, you get way more control over the variables and how you can configure them, but there will be more on that later. The next big point is customization. So there is a very long list as part of the OCPP spec of what standards components are included, standardized variables as well. But that is not enough because, as we know, things do keep changing. New trends keep happening. There will be new hardware and charging stations as things change as well. And the device model is open to that. So there will be hardware that we haven't discovered yet or haven't kind of put into practice. And that will fit in quite nicely with the device model, as you'll see in the structure later. And the final layer, which is very important, is the monitoring aspect of it. So once you have all this data about the charging station, about all its variables, the way you can configure it, you can then add an additional layer on top of it, and that is the monitoring that happens, and that can be also completely configured by the charging point operator. So they could say, for example, that they would like to be alerted if a fan starts overheating, or if a connector is broken. So these things do really open up a whole world of possibilities with the device model.
If I may jump in on that one, discussion we had lately with a charging station network operator was they were very interested in understanding what's the level of the coolant liquid, for example, for their high power charger, right? Because if the coolant liquid level is under a certain threshold, that means that this charging station, this HPC charger, cannot provide the full power to the car anymore. And imagine a Porsche Taycan driver who is expecting, I think it's like 270 kilowatt max to be able to charge, and he just receives, I don't know, 150 kilowatt because, the coolant level is not able to cool. that cable good enough, the charging station network operator would like to know that beforehand so they can fill up the liquid level and not have disappointed drivers in the end. I thought that was a very, very interesting use case for monitoring.
Yeah, and you get into the world of predictive maintenance as well, where you can start really getting the value out of the specification. So you get to a point where rather than having to send people onto the field, you're actually solving these problems proactively, and thereby saving quite a lot of money.
Yeah.
But yeah, so that was the kind of the overview of the device model. I think the next slide is probably for Chad, so I will pass on to you, Chad, for this.
Sure. Okay, hello everyone. My name's Chad. I'm a developer at Switch, and recently I've been working on the implementation of the device model in our software here. So I'm going to go a bit more technical. So any developers in the chat or any other questions, please just use that ask a question feature, and we can get to that at the end. So the device model, we've come from quite a high level all the way into the device model. Now I'm going to go even deeper into what the device model is actually made up of. And we've got 5 points here of really like the core components of what you need to be thinking about when we say device model. So components and variables are the foundation of the device model. And components, very important to remember that there's two types of components. When we use that word, it's describing two different things. We have controller components, which if anyone is familiar with OCPP 1.6, is quite similar to a configuration key. So 1.6 doesn't have a device model, but has configuration keys. And these are basically settings. You can think of them basically just as settings for the charging station. But then the new type of component in the 2.0.1 is the physical component. So this is like a fan or a connector or anything hardware related you can think of. The next point is the 3-tier model. So you have general physical components like fans, but there's 3 special components which are required for a charging station. And these are the charging station itself, the EVSE, and the connector. I'm sure everyone's familiar with what these are and these terms. And each of these can have their own subcomponents. So these are kind of like special components which can have their own components, and they form the kind of basis of the structure of what the charging station is. Attributes and characteristics. So these are kind of descriptive fields of a variable. So within a component, you might have a variable which is, the connector type, for example. Attributes and characteristics kind of describe more detail about the variable. So an example of a characteristic is the unit. Like you might have seconds for, a heartbeat interval, for example. And an attribute is kind of like the core description of the variable. So an attribute contains the value and also the name of the variable. But you can also have multiple attributes like targets and minimum and maximum. So you might have a target fan speed, and you might have a minimum fan speed, and you might have a maximum fan speed. And these can all be kind of within one variable within the device model.
Chad, if I may just shortly interrupt, I see a question in the chat. Are you sharing slides? So I just wonder, are you guys seeing the slides, or is more than one person having this issue? Okay.
Jim can see the slides. Yeah.
All right.
If anyone else can't see the slides, then let us know.
Okay. I think it seems to be fine.
Mm-hmm.
Yeah.
Looks okay for me.
Okay. Good. Thank you, Chris.
So yeah, monitoring. As Hugo was talking about earlier, this is a really, really nice feature, and actually comes back to a business use case and predictive maintenance discussions, and is really, really powerful. So any variable can have a monitor added to it, and these are very flexible, and you can basically set upper and lower thresholds and kind of like periodic monitors if you want to. And then the charging station management system backend will get notification messages if any of these values have been breached or recorded as crossing in the wrong direction. So I'll talk about a bit more about this in the next slide, but monitoring is something really, really powerful. And customization. Another amazing feature of the device model is it's almost unlimited amounts of customization. You can add custom components, and you can add custom variables as well. So we've even heard about people using the device model to describe a kind of like solar array with batteries and stuff like that. And people are really going to town, adding random components and variables to the device model. And I think we're just beginning to see what you can do with the device model in terms of customization. And we're kind of just on the cutting edge of that side of things. And it's quite exciting to see how people are using it for weird and wacky setups. Next slide, please. Okay, so actually, let's go back a second. I'm going to share my screen now, and we're going to look at some internal switch documentation of our device model setup that we have. So let me see if I can do this. I will share my browser. Is that working?
Not just yet,
I
Chad.
don't see anything yet, but
No? Can you see this?
Not just yet.
Okay.
Yeah.
Maybe I don't have permission.
let me fix this in a minute.
Yeah, so if we go back to the slides, I can talk about the physical component example we have. If you, yeah, the next slide after this one. Yeah, okay, they're back. Can we go to the next slide? Yeah, perfect, thank you. So this is an example. You can see the JSON here is quite long. It's actually going over the page there. But this is an example of a custom, or actually this is a standardized component. So another distinction I forgot to mention was we have controller components, which are very well defined in the specification. And then we also have physical components. And within physical components, there are standardized ones, which the spec describes. And this is an example of that, an air cooling system. And then you also have custom components, which I'm not going to go into now, but that's, as I said, there's tons of options for those. So standardized components are basically physical components, which the specification is kind of showing you a little bit of, they're kind of common components that people might be using on their charging station. So an air cooling system, basically a fan, or some other kind of, I would just call it a fan, is a very common component that you'd have a charging station. So the specification does actually define this for people who want to add this to their device model. And here we can see the structure of what that might look like in the device model. So you can see there we have the name, and then we have the EVSE. So in this example, I have prescribed that this fan is specifically cooling the first EVSE with ID 1. And then you have a list of variables. And again, you can have custom variables in here, but I've just put 2 in here. So we've got problem, which is a very common variable, which basically says, is there a problem right now? And if there is a problem, there's certain messages in OCPP that will report that to the CSMS. And then the second one there on the right is fan speed. So this is a more interesting variable. And here we've got, as I was describing, the attributes where we're saying the value is 350. But to know what 350 means, you have to look into the characteristics of the data type there is incorrect. The data type should be integer. And we're saying this does support monitoring, and the unit is RPM. So the unit, it can be any string, but basically this means when I go into my CSMS and I'm a charging point operator, I can look into my device model settings, and I can see that the value is 350. It's a read-write, so I might have an edit button. I can change this value, and I can have my units there in the CSMS. So it just makes it, all these attributes and characteristics really make it easy for the charging point operator to kind of understand how to interact with that variable. And then at the bottom there, we have variable monitoring. So this is just an example of a monitoring setting that the charging point operator might have put on. So I've just said, I put a lower threshold monitor of 300 on, severity 2. And if that threshold gets breached, then I'm going to get a notify event request from the charging station to the CSMS. And then within the CSMS, it's up to the operator or the implementer of the CSMS what to do with that. But you can imagine, getting an engineer to be notified when that is breached. And this is exactly what Hugo was talking about in terms of saving the operator money, because if I know that the lower threshold is breached at 300, I'm not going to wait until the fan is completely broken. I can go and replace it now, and then I have no downtime, right? So those stats we saw earlier with, 1 in 10 chargers in the UK being broken, there's potential to, improve those numbers with something like device model monitoring.
And we can now share also the device model, so we can jump into that if you want.
Brilliant.
Chad.
Okay, cool. So this is some documentation from Switch, and this is some of our internal messaging. So this is basically messaging that we're sending within the charging station from our OCPP module to the kind of hardware module within the charging station. And this basically allows us to keep our CSMS up to date with what's in the charging station, because the device model needs to be stored kind of in the charging station so it knows, what's going on and when values get breached. And then also in the CSMS, so the charging point operator understands what the charging station looks like, and it can update values. So what happens here is we send a request from our OCPP module to the charging station. And then if you just click on response there, this is an example of kind of this is actually a minimal device model. So we're kind of in the middle of implementing this, but this is kind of like the smallest version that you'd have. And as you can see, there's a lot going on. But maybe let's just stop somewhere. It's gone a bit blurry for me. If you just go down a little bit and maybe stop on line 80. Yeah, just down a little bit more. Yeah, just so we can see the EVSE. So yeah, here's an example of a physical component, one of the 3-tier model components that I was talking about. EVSE is actually a list of components, because obviously you can have more than one EVSE on a charging station. And again, we assign it to the ID of ID1. And then we have a load of variables that are associated with an EVSE. Availability state is a good, easy one to understand. This EVSE could be occupied, or it could be available, or it could be reserved or unavailable. And that's actually a variable within the device model. And then if you go down again, what would be good to show is an example of a controller component. So let me just find a good line for you to go to. Go to line 772, right at the bottom. It's, big document.
Yeah, big document.
This has been my life for the past couple of weeks. Okay, so transaction controller. So transaction controller obviously isn't a bit of hardware. This is kind of just settings, and some of these actually relate directly to configuration keys within OCPP 1.6. So an example is EV connection timeout. So this is like how many seconds, if you unplug your EV, how many seconds should you wait until you kind of time out the transaction? And if you go down a little bit more, Ben, to the bottom, a little bit more, we have, transaction start point and transaction stop point. These are really important variables, and these basically define what kind of events would trigger the starting or stopping of a transaction. So this is all up to the implementer of the charging station or the manufacturer, and you can start a transaction but based on an RFID reader, which is the authorized, or you can start one when the cable gets plugged in, and these are or you can do either, and this is kind of where you would set that in the device model. So yeah, that was just a little peek into the kind of developer side of things and what this actually looks like in reality. And yeah, if we go back to the slides, I think I'm going to pass back to Marc.
Yeah. Thanks, Chad. That was a really, really good insight. And I hope, despite the complexity of OCPP 2.0.1, you can see that its power and also how to apply it and get a grip of it mentally, how to apply it. That is basically one part of the complexity, half of it. The other side is, how do you actually visualize this rather sophisticated device model in a charging station management system? And that's where we have, put a lot of effort in the last months in our solution called Sarah. And maybe if you could just show this slide here. Can you zoom in a little bit potentially so we see the graphic a bit more? All right. Yeah, that's good. So I hope you can all see it well. And what you see here is basically when we focus on the center part, on the left-hand side, you see this Holborn fast charge, which is available right now. And then you see the station level. And on the station level underneath, you have a list of controllers. The auth controller, which is the authentication controller, the clock controller, the device data controller, OCPP communication controller, security controller, and the transaction controller that Chad was just referring to and giving you some information about. So these are all logical components, not physical components, right? And they reside all on the station level. And underneath we have then the EBSE level, which then has a connector, which in this case, in this example, is a CCS connector. And under that, you have then further physical components. So if you, within Sarah, you would then click on, for example, the transaction controller, and then on the right-hand side, you see all the kind of variables you can set. As Chad said, if it is a read-write variable, then you can actually edit it. If it's just a read-only variable, you cannot change it, but you can at least see what's going on. And by clicking on the Save Updates, that would actually trigger an OCPP message to change the configuration as you set it here. And in the middle, you see the charging station. Our idea, our goal is to give you a very, very easy to grasp representation of the charging station and all its components. So where it sits, the smart meter, the controller, the connector, that you click on it, and then you can actually quickly jump to that specific part of the device model without, getting a PhD and reading the whole spec to understand it. That's our job, to make it as easy to understand for you as possible. That's it so far as we want to go into the device model. Again, if you have any questions, please shoot them in the Ask a Question section. We will come to it in a few minutes. What we didn't do at the very beginning is start with our first poll. So that's what I like to do now. If you could just get up the first poll. And what we like to know from our audience is, on a scale from 1 to 4, what is actually your experience with OCPP 2.0.1? All the way from zero knowledge to I'm in a state of implementing OCPP currently. Do we see it here? Yeah. Okay, so let's give our audience, like 30 seconds or so? Sounds good. And let's see. Interesting. So it seems like the majority of the audience so far has had some level of experience with OCPP, looked into the specification even. And the minority of it has yet implemented it, which is to be expected because it's a rather new specification. And talking to companies in the industry, we hear still a lot of hesitance or hesitation towards OCPP 2.0.1, mainly for two reasons. One, it's not backwards compatible, unfortunately, with 1.6, but for a good reason, because you bring all these new features, all this sophisticated flexibility, and at some point, there is no way to keep this backwards compatibility. And OCPP 2.0.1 is quite a beast, so to say. My team has been working on it for many months already, and we aim to be one of the first to be fully certified for 2.0.1 OCPP, but it is a lot of work. And depending on your charger, if it's a AC wallbox charger at home, or if it's an HPC charger in the public, you don't have to implement everything in OCPP, right? So there are different certification profiles, and depending on your use case, you pick what you need to implement. Okay, so I think we are at the end of the poll. Seems like we have the minority have at least seen webinars on this topic. The majority has peeked into the specification. A fair amount of people who have no knowledge at all. And that's also great, and that's what this webinar is for. All right, I think we have time for the second poll. In the second poll, we would like to know from you guys, when do you see OCPP in the market? Or specifically, when do you want to bring it into your products, be it charging stations or be it back office systems? If you don't have a product yourself or are not working for a company that works in this domain, then at least when do you see this product or this technology come into market? Is it within the coming 6 months? Is it within the next year? Or is it within 2 years? I see we had a missing choice already implemented. Sorry for that, Peter. Okay, we already see a strong tendency towards within the next 12 months. That's interesting. The minority believes it's coming within the next 6 months. That's also what our feeling is. Okay, a couple of more seconds, but I do think the tendency will not change. All right, very interesting. Okay, so the majority believes within the next year, OCPP 2.0.1 is coming to market. Would also be interesting to hear what is the reason behind that. What features do you think are the main pulling force for OCPP 2.0.1? Since that is not a real question, you might just as well answer in the chat section. So is it security? Is it the integration, the seamless integration with ISO 15118? Is it the power of the device model? We would be really interested in your opinion in that. Good. I think we are just on time because we wanted to leave like around 15 minutes at the very end for the Q&A section. All right, shall we head to the Q&A section?
Yeah. So quite a few questions from everybody. So thanks very much for raising the question. We've only got 4, so continue to post them if you've got any. We can answer them. Even if we don't get to answer them today, we can answer them for you. So the first one came in when you were discussing the features, Hugo, from Andrea, regarding bidirectional power transfer and whether that is a feature of OCPP 2.0.1. So perhaps we can have a discussion on that.
Okay. And click on the answer question. So we have a timestamp.
For bidirectional power transfer, I believe that's in a -20, isn't it, Marc?
Answer question. There's a button. There should be. Okay.
So the question is around bidirectional power transfer. I believe that's a V2G question, which isn't in 2.0.1. That would be in the next version of OCPP. And as it's used with customizations. So not at the moment, but it's being worked on.
Yeah, there's a V2X task group within the Open Charge Alliance that is working on this whole bidirectional power transfer topic. As far as I remember, the idea here is to try to adapt 2.0.1 with custom data to bring in some of the V2X features into the current spec. But we will see in probably 2.1 or 2.2, whatever the version will be, a full support of BPT.
I can see there was another question that was voted more, which was around the auto discovery process in the CSMS. So yeah, I'll just expand on that a little bit. What we mean by auto discovery is that whole JSON blob that you saw that Chad was sharing, that is shared kind of as a charging station is booted up for the first time. So the first time that a charging station connects up to a backend, it will give the base report and can also give a full description of all of its logical components, like the transaction controller that you saw, and its hardware components as well. So at that point, the backend gets a full picture of all that the charging station has. As you saw, like that JSON can be quite big, so that can be split up into multiple messages as well for efficiency. But that is pretty much how the auto discovery process works. It's kind of at startup giving all the information that the charging station has at that point to the CSMS, and then the CSMS can then decide to modify any configuration that it would like to do at that point in time. Some of that configuration of the CSMS can be automated as well. So it might be that as a network operator, you always want certain settings to be enabled or disabled on the charging stations that you manage. So at startup, when you receive the configuration, you also set those variables, which doesn't need any manual intervention. Yeah, hope that answers the question.
Great. Next question.
So,
by the way, I forgot to properly introduce Adam here, our head of product, who was so kind to help us with the moderation of the questions.
Thanks for the intro, Marc. Hello, everyone. So yeah, next question is from Ismail. So regarding legacy chargers, how to deal with legacy chargers in the network that are not compatible with all the new standards that we spoke about.
Yeah, that's a tough one. I mean, first of all, the question is, to which degree are they equipped when it comes to ISO 15118? Do they have the home plug green-fi modem, right? Because that's a hardware prerequisite to communicate with the electric vehicle over power line communication. That's just the ISO 15118 part. With OCPP, I mean, it's basically just a software over-the-air update, right? Depending, is the charger able to do these over-the-air updates or not? Also a question of how much memory space is available to store certain certificates, for example, which we need for the security part. I do think we are able to deal with integrating or migrating this installation base of 1.6 into 2.0.1 quite easily, but it makes it easier if you can just over-the-air update the software. But I don't know to which degree this is possible with the current installation base. I'm not sure if that sufficiently answers the question, but that's my take on this. Is there anything you think we should add?
I mean, for OCPP specifically, it is not backward compatible, but there is a large degree of overlap. So depending on the charging station, if you have that, if the charging station itself can be changed to include the new standards, that's what would be required. On the backend side, what we expect to see is that CSMSs will progressively support 2.0.1 more and more, and we'll enter a transition phase where CPOs will have to be managing charges from both different versions. And as we move over to 2.0.1, we'll get more and more of those there. I think a transition period is inevitable in a way, because we can't forget about the legacy infrastructure that is in place. But I think we shouldn't forget as well that the number of chargers, at least in the UK, that we are installing, it's not on a linear trajectory. It's more like exponential at the moment. So the sooner we move to 2.0.1 and get to that, get early on in the exponential curve, the more 2.0.1 chargers we'll have to manage in the end. So that's where it's important to try and jump on that new technology as fast as we can, because then it also means that the legacy problem will be less important.
Great.
Okay. Thank you both. We've got another question here regarding, two-part question regarding the status of ISO 15118-20, and also how different will that be to ISO 15118-2?
How different will it be from -2 regarding implementation and programming language used? Well, so as a matter of fact, ISO 15118-20 has been published today. I just got an email that you can purchase -20 on the Beuth Verlag. Just don't know what's the English word for it. So you can purchase it online today. -20 and -2, they themselves are also not really backwards compatible. Unfortunately, that is just due to the nature of how these messages are described with XML data structures, but I don't want to go into that detail too much. So let me get back to the question. Is there any update about -20, and how different will it be from -2? I mean, there are mainly a couple of features that -20 brings to the table that we don't see yet in -2. And I do see the strongest pull from the vehicle-to-grid functionality, so bidirectional power transfer for both AC and DC. That's why the combined charging system, of which ISO 15118 is a part of, is more and more becoming a dominant standard, because it just covers all the necessary use cases for any kind of electric vehicle, be it a car, be it a truck, a motorbike, a ship, or even small passenger airplanes that we've seen on the charging festival so far. So vehicle-to-grid functionality is a big pull towards 15118-20. We also have a new feature of wireless charging, and also pantograph charging for buses using the so-called automated connection device, ACD, and also a high level of security. So there is no way around an encrypted communication anymore. It's all TLS 1.3. And another very nice feature is the explicit support for various contract certificates that you can install on the vehicle, which is already possible with -20, but it's not as outspoken of a feature yet, that you can have more than one contract certificate. And for those who don't know what a contract certificate means, it's basically the identification token stored inside your electric vehicle, which enables the plug and charge feature. So you just plug in, and then the car identifies itself towards a charging station and then towards a back-end system as a car that is authorized to charge at that charging station. And then you can imagine use cases where you have a certificate related to charging at your workplace, where you charge for free, and maybe you have another certificate from a different service provider where you charge at home or at public charging spots on your own costs, for example. So vehicle-to-grid, several contract certificates, a higher level of security, wireless charging, pantograph charging. I think these 5 are very exciting features, but the most important one is for sure vehicle-to-grid. All right.
Great.
Next one.
Thank you, Marc. I think we've got time probably for one more question, depending how it goes. But there's one here from Jim regarding the legacy of 1.6 and moving over to OCPP 2.0.1. So Jim said, in the USA, most backend providers use 1.6 with no short-term plans, i.e. 2 years, to convert to OCPP 2.0.1. Perhaps one we could discuss around the importance of moving over and the process of moving over.
I mean, the US is a little bit behind when it comes to implementing those standards as compared to Europe, right? There's also, a less fragmented market, also when it comes to roaming, that is very mature in Europe and not so much in the States. I mean, I think one major reason why companies hold back on 2.0.1 is the big effort associated with that, the big costs that come with it. That's where we as Switch try to help, because we see us as an enabler. So we want to build the bulletproof foundation for the companies that want to build their business use cases on top of it without everyone having to reinvent the wheel and implement the standards from ISO 15118 to OCPP 2.0.1 over and over again, which in the end often comes with interoperability issues, and that can be the way forward in this industry. Yeah, that's basically my take on that answer, on that question here. I think we are basically out of time. There is a, if I'm not misinformed, a call to action. So if you want to learn more, if you want to get in touch with us about OCPP 2.0.1, maybe you're interested in Joseph or Sarah, there is a call to action link where you can set up a meeting with us. And any other question that we haven't answered yet, sorry for that. We ran out of time, but we will be happy to answer those questions after this webinar. We'll probably add a PDF with our answers, attach it as a link to this webinar, and you just need to view the same link, and then you can rewatch this recording. All right, Hugo, Chad, and Adam, thanks a lot for your help, participation, and the work we put all together. Personally, it was a great fun for me, and I hope we have a lot of people out there to better understand the potential of OCPP 2.0.1, and maybe this way also help accelerate the adoption of this really future-proof technology. And yeah, we hope to all see you next time. And I will get in touch with you guys to ask you also what would be the next topic that we should talk about. Is it more about OCPP? Is it more about ISO 15118? Is it maybe a completely different topic related to these standards? Would be great if you could, let us know. Maybe we should, which the best way for them to reach out? Maybe let's do it this way. In the Ask a Question section, just put there what is the topic that they would like us to talk about next, and then we will discuss internally. I think that's probably the best approach. We will give you guys 1 minute, and then we'll probably call it off. Anything to add?
Not for
Chad,
me.
Adam? All good?
All good.
I think we didn't forget anything that we want to cover. So I see, oh, actually you can put it in the chat. That's probably the easiest way. So ISO 15118-20 is very likely a very hot topic. -20, we see coming up again. Interesting. Okay. Well, we'll probably also send out a survey very soon, where you can basically provide your input for the next topic, because we want to make this webinar series as relevant to you guys as possible. That being said, thank you all for joining. It has been a blast, and see you next time. Bye-bye.
Thanks a lot, everyone.
Thank you.